1, 2, 3, funk it.
My darling, I love you, 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 I love you.
Okay, and reduce the impulsive force. So this will reduce injuries. Okay, so next one is this one. Okay, I think you guys have seen before, like, during those sports day. Okay, like those jumper, right? Okay, like this, and this is the sand thing. Yeah. So for the jumper, okay, long jumper, they want to jump, right? So what happened is like they will just jump early, this, and then he'll be like this. Okay. So okay, so yeah, basically, right. Okay, I know I'm lagging. So yeah, basically, right, the person when he jumps, he'll jump over the pit of sand, and then like this. Okay, and he will just like land like this okay, and here there's also sand by the way. So yeah, so what is the function of the sand is that, okay, so this kind of sands, right, they are very loosely arranged. Okay, they are just like really loose. So the function is like when the long jumper lands on the sand, it will actually lengthen the impact time, and this will reduce the impulsive force acting on him, and of course reduce the injuries. Okay, so yeah, and the third one is this thing. Okay, so I think you guys like seen before those match, like those baseball player, like catching the ball thing. Yeah, like this. His hand will like move backwards like this. Okay, so basically, right, what is the function of this thing is that, okay, when they move when the person, right, when this baseball player is moving his hand backwards, actually there is a function, because when he moves his hand backwards, it will lengthen the time. It's like, like the ball, right, it's like flying so fast, okay, and hitting on his palm. Okay, so let's just imagine you're catching such a fast ball, and to reduce the injuries acting on his hand, on his palm. So what happened is this person, he will actually move his hand backwards, like bend it a bit, okay, backwards, so that it will actually reduce the final velocity of the fast moving ball. Okay, so when it reduces the final velocity, what happened is like, yeah, mv minus mu over t, right? Okay, so you can't change this one, by the way. So yeah, you can't change mass as well. So when your final velocity is decreased, so like I said just now, means that your whole momentum is decreased, right? And your impulsive force will be decreased. Okay, so yeah, that's the idea for. And the other one is the glove as well. So the glove is usually made of soft material. Usually it will be leather. Okay, so this leather will be able to lengthen the impact time. So when the person catches the ball, it won't actually have a really large impulsive force acting on it. Okay, and again, it will prevent injury. Okay, so yeah, so far okay, right? Okay, yeah. Okay, so okay, let me see like how many slides do I have? Give me a minute. One. Okay, so yeah. Okay. Okay, so for this one, I'll just pick two more important examples. Okay, so first one, okay, pestle and mortar are made of stone. Okay, have you guys seen before those pestle and mortar, like those traditional one? Yeah, this one. Okay, this is pestle and mortar. Have you guys seen before? Okay, yes. Okay, so basically what we do is, usually like those your mom okay, or your grandmother, okay, what happens is they will put those spices like chilies, garlics, and all those. So basically they will just cut it into small pieces and put everything together here. Okay, so what happened is when Okay, so what happened is, when the pestle is used to pound the spices like this, okay, so yeah, this thing is like, pouncing it, like, hitting it. Because of the hard surface of the mortar, what happened is the impact time between the pestle and the mortar means like this thing, okay, this thing and the mortar, which is the bowl thing just now. Okay, so the impact time between the pestle and the mortar is very short. And again, when we have a very short impact time, so it will produce a large impulsive force. And that's the reason why the spices can be crushed easily. Okay, and next one is a golf club. Okay, so a golf club is like, yeah, this thing. Yeah, and this is the golf ball. Okay, so yeah. Okay, so basically this golf club, right? Usually it is made of very hard materials like steel. Okay, so the reason why we use steel, steel as a golf club material, because we want it to be very hard surface. Okay, we want it to have a very hard heating surface, so that when you have a very hard heating surface, right, what happens is when the golf club hits the golf ball, there will be a shorter impact time. Okay, so when we have a shorter impact time, again, we will have a larger impulsive force acting on the golf ball. So basically, right, because there's a large impulsive force acting on the golf ball, so the golf ball can actually travel further. Okay, and yeah, finally enter the whole thing. Okay, something like this. Okay, yeah, and yeah, something like this. Okay, next one, we proceed to this one. Action reaction force. Okay, so Newton's third law is about action reaction pair. So it means like it's a little bit like the explosion just now. Means every action force has a reaction force of the same magnitude, but in opposite direction. Okay, so what does it mean by this? So let me give you an example. For example, like a book. Okay, this is the book, and then this is your table. Okay, so according to Newton's third law of motion, right? Because there's a reaction force of same magnitude. So means what? When your book is stationary on the table, okay, guys, there's actually two forces acting on the book. Do you guys want to know what's the two forces acting on it? Normal force and gravitational force. Yes, that's right. Force, and this is your normal force, or what we know as reaction force. Okay, normal force. Right. So yeah, and because of this, right? Because of this, because there's a gravitational force why the book is on the east corner edges, so all the way along the book, because there's a force. So yeah, you guys realize same magnitude but in opposite direction. Okay, one is up, one is down, something like this. Okay, so how do we increase impulse? So there's one thing, which is what we know as what we know as follow through action. So the idea of follow through action is like this: when you have a ball, like football, okay, when you kick it right, let's just say like this. Okay, you kick it, and then right, in order for you to make it go further, and then you want the ball to be like travel further, and score it. Okay, what happens is like the football player, they will actually have this kind of follow through action. Means like they will follow it, you realize that the direction is like this, and then the person's his leg is like following the ball direction. Okay, so he will kick it from here all the way along to here. So why is it a follow-through action, it will actually increase your impulse overall. When it increase, what happens is your final velocity will also increase. Okay? So when your final velocity increase, means your ball can travel faster and further. Okay? Yeah, something like this. Yeah. So if no questions, then I proceed to the next one. Okay. So yeah. Okay. So yeah. Okay, so for weight, right? Okay, so weight, what's the definition of weight? So weight is the gravitational force acting on it. So for the formula, W equals to mg. Okay? So it is a gravitational force acting on it, and it is a vector quantity because it has the same direction with the gravitation, which is towards the center of the Earth. Okay, so whenever the question is giving you like information, like they like to use like this kind of word like gravitational field strength. Okay, it looks like very complicated, but it is actually the same as gravitational acceleration, which is 9.81 ms negative 2 on the Earth. Okay, so for the ratio of Earth to the Moon, it's actually 6:1, meaning to say if let's say on the Moon I am 100 Newton. Okay, that means on the Earth, what's my weight? Okay, very good, guys. So this will be 600 Newton. Okay, yeah, that's right, Yuan. So yeah, okay. So I have two questions for you guys. So first, how do we differentiate between mass and weight? Can you guys type in the chat box, like what's your concept between mass and weight? Mass, no direction. Yeah. Okay. In other words, is scalar quantity. Okay. Yep. That's right. Okay. First point. What's that? What about the unit of mass is kg. Unit for weight is Newton. Can also. We talk about the properties. Yeah. I think actually it's like about 2 or 3 only. Yeah. Mass is constant. That's right, guys. Yeah, Kiara also right. Weight changes depending on the gravitational acceleration. Okay, so this is what I want to emphasize on. Always remember that mass is constant anywhere. Okay, so let's just say on the Earth you are 10 kg, and then on the Moon, on the Saturn, wherever lah, okay, Jupiter, wherever, like what kind of planet you can think of, you will always become 10 kg. Okay, you are always 10 kg. But what makes the difference between mass and weight is that because mass is like, mass, okay? Then weight, right, is actually a formula like derived from this. You realize, right, m is inside. So yeah, when your mass is constant, means that your weight is always depending on your gravitational acceleration. So, meaning to say, your gravitational acceleration, if this increases, and your weight will also increase as well. Okay, so guys, okay, according to this ratio, right? Can you guys guess like the gravitational acceleration of the Earth versus the gravitational acceleration of the Moon? Which one is like higher? Earth. Yes, that's right, guys. So yeah, Earth. Okay, because yeah, like I said just now, because when this one increase, your weight also increase together. Okay, So yeah, that's the idea. And by the way, guys, just fun fact, okay, moon is like 1.62 ms negative 2 the gravity acceleration on the moon. Okay, so yeah, okay, that's right. Okay, and the second thing is the value of G, right? It depends on two things. Can you guys guess, like, what are the two things? I know it's a bit hard, but yeah, this is like a bit I think it might be quite helpful as well. Yeah, I think it's in your textbook also. Mm-hmm. Um, wait, what was the question? The value of numbers. Anyone? Like, if you guys like feel like it's a bit weird, but it's in your textbook. Okay, yeah. So anyone wants to try? Mm-hmm. Mm-hmm. There's 1 point, Yongjie. Mass of okay, Yongjie. Answer is correct. The distance between the core, which is what we know as the center of the Earth, and also not the out layer lah. Okay, it's like yeah. Okay, so I think you guys can guess it lah. Okay, so let me just oh my god. Okay, yeah, let me just show you guys the answer. Okay, so value of G depends on two things. First one is the distance from the North Pole or equator to the center of the Earth. Okay, what does it mean by this? Okay, guys. For Earth, a sphere, like not a perfect spherical body. Okay, it's actually a little bit like oval. Okay, so this is the center of the Earth. Okay, and this is your equator, or in geography, I think it's called as what's it called? Khatulistiwa, right? Yeah, something like that. Okay, I'm very bad at this. Okay, and yeah, this one will be your North Pole. So the center of the Earth is actually like shorter. Okay, so because of this, right? Because this one is shorter, so this D is like shorter. So this means what? Gravitational acceleration will be higher. Okay, because right, it's like nearer. There will be a stronger pull of gravitation. Like there will be a stronger gravitational pull. Okay, that's why higher lah. Okay, so yeah, the nearer it is, there will be a stronger gravitational pull, and that's the reason why North Pole will have a higher gravitational acceleration. For example, I think it's like 9.8 something and as compared to equator, the gravitational acceleration will be smaller because it is further. Okay, and the next one is height above the sea level. So sea level is like this, like like those mountains, and we always heard of like how many feet from the sea level and all those. Okay, this one is not very important but this one, yes. Okay, this one is like the higher you are, okay, like as compared to at the foot of a mountain, okay, the smaller the gravitational acceleration. Okay, so yeah, mainly is this one I want to cover this one. Okay, so yeah, all good. If yes, then we can like try some questions. Yeah, you guys understand? If you can, then we proceed. Okay. Yeah. 3, 2, 1. Okay. So yeah, guys. This one is good. Yeah. Okay. This is a simple question, guys. This is kind of like a ratio question Okay, so let's do it together. So first, an astronaut of weight 1779.6 Newton on Earth weighs himself on the Mars surface. The reading on the weight machine shows 296.9 Newton. So this one is like weight on the Earth, and this one is weight on the Mars. Okay, so what is the Mars gravitational field strength in terms of Earth's gravitational field strength? Okay, so they're asking Gm is what in terms of Ge? Okay. So basically, right, I want to explain this question. So still remember, weight is W equals to mg. Okay, and as you guys know, mass is always constant anywhere. So whether you are on the Earth or on the Mars, it's the same. Okay, 10 kg means 10 kg. Okay, so because my mass is constant, right? Can I say that, like m of mass equals to m m of the Earth. Yeah, something like this. M of the Earth equals to m of the Mars. Okay, so the m equals to W over G. Okay, you just move it around. This is max. So WE, okay, weight of the Earth over the gravitational acceleration of the Earth equals to the weight of the Mars over gravitational acceleration of the Mars. Okay, so if you guys stop inside, what's the answer? Like in terms of GE. So I want GM equals to how many GE? Oops, wait. Let me check. Anyone wants to try? Yeah. Let me check the answer. Oh, wait. Okay, guys. Let me check the answer also. Okay, the answer is 1/6. Okay, I think just now, Esther will send this question, this answer. Okay, yeah. Okay, so guys, yeah. Equals to 26.9 over GM. So the rest is like your max. G equals to G equals to G multiply 296. Wait. Yeah. And 6. Youngjae, because they want it in terms of yeah, so I think like usually for this kind of compare ratio question, it is better you write it in terms of fraction. Okay. Of course, if you have decimal place, like you really can't do it, then you just write in terms of decimal place. But usually for this kind of compare question, it's in terms of ratio fraction.